Hey everyone, Mr. Fransky here. Today we're going to be talking about 2.7 in pre-calc. It's equations in one variable with rational expressions. So rational number has that word ratio, and it means it's going to have some kind of a fractions, maybe like in 3 over x, something like that. And so we're going to be able to solve equations that have rational expressions in one variable. Let's take a look. So some vocab we're going to see, least common denominator, which sometimes you call LCD. We've been dealing with that when adding any kind of fraction, right? Extraneous solution means an extra solution, one that is not actually a solution. And then we're also going to talk about clearing fractions. So we're going to start off with some bell work here. Just want you guys to try to solve this equation for x. We've seen stuff like this before. So why don't you give it a shot, pause the video, and then come back. All right, let's see how you did. So what I would do first here is I would multiply by something that gets rid of the fractions. So 4 we'll get rid of over here, but not over here. 3 we get rid of this side, but what can I multiply by to get rid of everything? I think if I multiply by 12, that'll work. So on the left side, 12 times 1/4, that's 3, because a fourth of 12 is 3. So I have 3 times x plus 6 equal to 12 divided by 3 is 4, so I have 2 times 4 times x plus 1. Right, 12 divided by 3 gives me 4, so 2/3 times 12, right? Oop. I just take that, 12 over 3 is 4, so it's 2 times 4. Okay, remember you can always just do that in any order that you want. All right, so let's distribute now. So I have 3x plus 18 equal to, this is 8x plus 8. So let's see here. Let's get all the x's on the right so they're positive. So I have 5x if I do 8 minus 3. And if I subtract 8 from both sides, I have 10. So it's like x is 2. There we go. Not too bad. So what we're going to look at in 2.7 is, can we do this with x's in the denominator? So same deal, but just a little bit different, because now instead of a number in the bottom, I have an x in the bottom. But let's see what we can do. What can we multiply both sides by to get rid of all of the fractions? I think multiply by x, it'll go away, right? On the left side, we'll have x squared. I'm distributing it to both parts. X squared plus 3, because the x's cancel there, equals 4x. Now let's subtract 4x from both sides. So I have x squared minus 4x plus 3 equals 0. Now, why did I do that? Because we can only solve quadratics if we have it equal to 0, right? That's kind of the goal with quadratics, get it equal to 0. Then you can use quadratic formula, or you can factor, or you can complete the square if you want to, and that'll be able to solve for x. So now let's see if we can factor this. X and x equals 0. Positive 3, negative 4 is a negative 3, negative 1. So what are my options for x? X could be 3, or x could be 1. Now, it's always good to back and check your work. So let's check up here. 3 plus 3 over 3 is 3 plus 1, which is indeed 4. That works. And 1 plus 3 over 1 is 1 plus 3, which is also indeed 4. That works. Cool. All right. So let's dive in a little bit more here. So this is the real deal. This is about as hard as it gets. So let's take a look. So what we're going to do here is I have 2 minus 3 over x plus 4, and I have 12 over x squared plus 4. I believe that's supposed to be 4x. Yeah, that's supposed to be 4x. Sorry about that. Make sure you change that to a 4x in your example. So what I'm going to do is I am going to see if I can figure out what I need to multiply each side by to get those fractions to go away. To do that, I'm going to factor the right side. So I have 2 minus 3 over x plus 4. On the right side, I have 12 over, what can I pull out of here now that I added it in there? It should be x times x plus 4. Now what we're going to do is we need to multiply both sides so everything goes away. Well, the x plus 4 will go away from both sides if I multiply it by it. And it looks like I also need an x. So I'm going to multiply both sides by x times x plus 4. Now some stuff's going to drop out, some stuff's going to stick around. On the left side, I'm going to have 2 times x plus 4. Minus, so for the 3 over x plus 4, the x plus 4 will cancel. I'll be left with a 3x. Then on the right side, everything goes away, so I just have 12. So what I'm basically doing here, remember, I'm multiplying both sides by the same thing. That 3 over x plus 4, when I multiply by x times x plus 4, the x plus 4 cancels. I'm left with just 3x. That's where that 3x came from. All right. So now let's distribute here. So I have 2 times x squared plus 4x. Minus 3x equals 12. Come up here. So we have 2x squared plus 8x minus 3x. I'm going to move the 12 over. Minus 12 equals 0. Because now we have a quadratic, and it's equal to 0. So we have 2x squared plus 5x minus 12 equals 0. Now we can factor that. 2x and x equals 0. Let's see here. So 12 could be 6 and 2, 4 and 3, or 12 and 1. Let's try 4 and 3 first. Let's try 4 and 3. Now I have to try both ways with this. Why is that? That's because we have the 2x over here. So when it multiplies on the outside terms, it could give us a different value, either 6x or 8x when it multiplies by 3 or 4. So let's see here. 3 times 4 is 12, so that 12 works out. 2 times 3 is 6, and 4 times 1 is 1. I can't make a 5 out of a 6 and a 1, so that's not going to work. Sorry, I can't make a 5 out of, what did I say, a 6 and a 4. Next up, I got 8 and 3. Hey, that works. 3 here, 4 here. Now I have 8x and I have a 3x. That'll make a 5x. I would have to have positive 8x, so I have to have a positive 4 times 2, and then come down 3x. So I have a negative 3 times 1. So now let's see what our solutions are. X could be 3 halves, because then the 2 would cancel and then the 3's would cancel. Or x could be negative 4. Now, just like we did before, we should check our work and see if it works. So 3 halves, I am not going to plug in here. It looks like we wouldn't have any issues, so you can check it if you want to. But the negative 4, let's take a look at. If I plug negative 4 in for x here, what happens? I get a 0 on the bottom here and a 0 on the bottom here. This is what's called an extraneous solution. Extraneous means you get it as a solution by solving the problem, but somehow it doesn't actually work to be a solution. And the reason that extraneous solutions end up happening is because when you multiply by x times x plus 4 here, you might pick up some extra solutions that wouldn't work in the original. So basically what's happening is if this should work for any value of x, but if x is negative 4 or 0, then I'm basically multiplying and dividing by 0, which is not allowed. So there's some values that don't work for multiplying this out. And all we have to do at the end is just check. Just plug it back in and see, does it make the bottom 0? That's all you have to do. So it sounds like we need a procedure for this. So let's take a look. So this is our procedure for solving rational equations. So the first thing you're going to do is factor all denominators. Uh-oh, there we go. Factor all denominators to find the least common denominator. Okay, find the least common denominator. So just like we did in this problem, right, we factored and then we said, well, we don't have to multiply, because some people just jump in right here and they say, got to multiply by x plus 4 and x squared plus 4. You can do that, right? This x squared plus 4 will cancel, this x plus 4 will cancel, but you're going to have a cubic then, which is a lot harder to solve. That would be like taking, like, I don't know, 5/12 minus 3/4. And saying, well, I have to get a common denominator, so I need 48 and 48. Well, no, you don't. You just multiply this part by 3, right? So same thing here. I didn't have to multiply by the entire thing. So factor all denominators to find the least common denominator. That's the first thing you're going to do. And then we're going to multiply both sides by that least common denominator. Multiply both sides by the LCD. Okay, what that's going to do is it's going to cancel some things out, right? We had that here. So multiply by x times x plus 4. The x plus 4 canceled from here. The entire thing canceled on the right. Okay, so some stuff will cancel out. And now we're going to solve for x. It's probably going to be a quadratic. So it's probably a quadratic. Okay, probably a quadratic. Then the last thing we do is we have to check for extraneous solutions. Check for extraneous solutions. Okay, and that just means plug it in. And the question is, does it make the denominator 0? And if it does, then it can't be a solution. If it makes the bottom 0, that would mean that we have an undefined point, and that would not work. Okay, that's really all there is to it. So you can probably just jump straight to the homework from here, but I'm going to make another video with a couple more examples. So I will see you there. Love you guys. That's why I'm here. Have a great day.